We're going to talk about rational functions and rational expressions. And you probably have not dealt with rational functions or rational expressions before, but I bet you've dealt with rational numbers. A rational number looks like this. Something over something, and the denominator can't be 0. So someone explain to me why in this particular rational number can the denominator not be 0? Why would having a denominator of 0 be bad? Or is it not bad and everybody's cool with dividing by 0?
When you divide by 0, you just get 0.
No. If you do 0 divided by something, you get 0. If you divide by 0, something much worse than 0 happens. Yeah, it's not only is it not a real number, it's an undefined number. It's not even a number anymore, real or otherwise. Dividing by 0 is definitely how the fifth horseman is going to bring about the apocalypse. Dividing by 0 is bad, bad, bad. It's so bad you can't even do it on a calculator. If you divide by 0 on a calculator, it gives you an error message, unless it's an old calculator, and then it will start smoking and sputtering, and the batteries will explode. So dividing by 0 is bad. This is such a problem with rational numbers that we're going to start off by figuring out values that a rational expression can't have because it would give you a denominator of 0. Now when you do that, when you find all the values that a rational expression could have, that is called finding the domain. And that's the first thing we're going to start off with. Having 0 in the denominator is so bad that we're going to actually stop and dedicate some time to how you can avoid making it happen. So let me give you an example of a silly expression. I'm going to use function notation. That's when you've got f of x instead of y equals. And I'm going to give you a really goofy, awful equation. So there is an example of a rational equation. The top looks like a nightmare. Don't worry, we will deal with the top of this rational equation soon enough. The bottom, though, is the thing I'm concerned with. And the reason I'm concerned with the bottom is because, as we set up here, the denominator can't be 0. So when I'm finding the domain, the question I'm asking myself is, will any value of x cause the denominator to equal 0? X can be 0. It's fine for x to be 0. I just can't plug in anything for x that would make the denominator equal to 0. So take a look at this equation. Is there anything I could substitute, any number I could substitute in place of x that would cause my denominator to become 0 and therefore bring about the mathpocalypse? What I'm asking is, what if I replaced the x with the number 0? What if I replaced all x's with 0? What would happen? Well, this would be 8 times 0 cubed, which is 0. This would be 7 times 0 squared, which is 0, plus 20. So on the top, I would have 0 plus 0 plus 20. So the numerator is 20, and the denominator would be 2. Did the denominator change when I replaced x with a number? No, it did not. Is there any value of x I could plug in that would change my denominator? Oh yeah, if I plugged in a fraction that had 0 in the denominator, that would be bad. You're right, you're right. So let's assume I'm plugging in real numbers only. Is there any number I can plug in for x that would cause my denominator to equal 0? And the answer to this problem is no. No, there is no value of x that would cause me to have a 0 denominator. So all values of x are okay. So how do I write that x can be any number I want to and everything's going to be fine? Well, here's how you write it. It looks really goofy. For now, all I have taught you at this point is real numbers. So when we say x is a real number, that might as well say x is any number you can think of. Now this symbol right here, are you familiar with that? What that line means? You know how to say that out loud? This is such that. So the way you read this, and you will really impress the ladies at the math party if you say it like this, the domain of x is x such that x is a real number. That's the domain. The domain is x such that x is a real number. That is a very impressive way to write that answer. If you are invited to a math party, that will make you the hero. So I think a fair question to ask at this point is, okay, if x can be any number I want to in this expression, what does it look like when x can't be just anything you feel like? So let me show you what that looks like. That's an example of a problem where x can't be anything you feel like. We're going to ask ourselves the same question that we did up here. Will any value of x cause the denominator to equal 0? So look at the denominator. If I made x equal to 0, if I said x was equal to 0, what would the denominator be? I'd have 0 minus 1, which is negative 1. Is it okay for me to have a fraction with a denominator of negative 1? Sure. So is there a value of x where I would get a denominator of 0? How about 1? If x was equal to 1, instead of being x minus 1, my denominator would be 1 minus 1, which would be 0, and that would be bad. A denominator of 0 is not okay. So 1 is the only one that's a problem. 1 is the only number I have a problem with. So I want to find a way to say that the domain can be anything you want except for 0. It can be any real number except 0. And here's how you write that. The domain is x such that x is a real number and x does not equal 1. And that's how I'd write the domain of that problem. X can be any number you want to, except 1.
Would you mainly encounter that if the denominator was anything other than a single digit?
That is such a good observation. This is only a problem if the denominator has a variable in it. If the denominator is just digits, x can be whatever you feel like. X can be any number. If the denominator has a variable, like x or y or z or whatever, pick the variable of your choice, then I have to worry about this. So you said x equals 1, and it feels like you just pulled that out of thin air. How did you know that 1 was going to be our problem child? Well, all you would have to do is take the denominator, x minus 1, set it equal to 0, and then solve it. What value of x would cause this to equal 0? You add 1 to both sides. Lo and behold, you get x equals 1. That's how we could figure out x could not be 1. If x was 1, it would cause that thing to equal 0. That seems like a pretty basic algebra problem, right? It's not too bad. So keep in mind, setting the denominator equal to 0 is how you figure out what x can't be. And also keep in mind that I told you we were going to factor basically every night of this entire class for the whole semester. And tell me what the domain is of that guy. So what I need to do is take that denominator, which is x squared minus 2x minus 15, and set it equal to 0. The question I'm asking is what value, or in this case values, of x would cause this entire thing, the denominator, to equal 0. Now x squared minus 2x minus 15 looks awfully familiar to me. Looks a whole lot like a problem I could factor. So how do I factor that? What do I do first? Is there a greatest common factor? No. Question number 2. Is there a leading coefficient? No. So then I can go to my 2 parentheses. They're both going to start with x. That's how you get x squared. What do my 2 numbers need to do? Multiply to be negative 15. And add to be negative 2. What are those numbers? You are so smart. Negative 5 and positive 3. Now we did these last week. How do I solve this when I've got 2 sets of parentheses and it equals 0? That's exactly right. I set each one of these parentheses equal to 0. Neither one of these is particularly difficult. I know you're all experts at algebra because you have the best algebra teacher in this building right now. Cool, so is my answer 5 and negative 3? No. As a matter of fact, 5 and negative 3 is the exact opposite of the correct answer. I was trying to find domain. What values can x be? And what I just figured out is that x can be any number you want to except 5 and negative 3. So if you said the answers were 5 and negative 3, you got this problem as wrong as it is possible to get a problem. You said the only 2 numbers that it can't be. So x such that x is a real number. I mean, you should take a certain degree of pride in that. You're like, no matter what I could have said, it would have been impossible for my answer to be worse than 5 and negative 3. That doesn't happen every day. I'm used to wrong answers. I get wrong answers all the time, but it is rare that I get the exact wrong answer. I think we're going to say nailed it. Nailed it.
So is there any particular order that you need to write this in?
That is such a good question. Is there any particular order? I would say no, but probably make is a real number the first part, and then what it can't be on the end. But the order of what it can't be doesn't matter.
No, I mean like the ones that it can't be, like largest to smallest.
Right. No, I don't think it matters one way or the other what order you put them in. As long as you get the correct numbers. Okay? So our goal here is to solve some rational equations. That's what we're going to move on to in a little bit, is to solve an equation. This is something you need to keep in mind as you're solving equations. When you solve an equation and you get an answer for x to these rational functions, you need to always check and make sure that the x you got is not one of the x's that it can't be. You got to make sure that you check that. Now, before we jump into solving the equations, there is one more thing that I need to show you. And that's how to simplify rational expressions. Rational expressions are basically like really fancy hardcore fractions. So when I say simplify rational expressions, you can treat it kind of like the same as if I said simplify a fraction. Simplifying a fraction means to reduce it. So that's really what we're doing. We're reducing rational functions. Okay? Now, in order to reduce rational functions successfully, you are going to have to get used to the idea that basically every problem you're going to do will in some way have some factoring available. So take a look at this problem. Do you see anything in this problem, numerator or denominator, that we could factor? Where do you see 2x squared as a possible factor?
Top and bottom.
So the bottom has a 2x squared in it at least, which is good, but that's not factor. We are going to need that in a minute, but not yet because that's not factoring. It's only got one term in it. You can't factor just one term. But we could factor 2x squared down here, couldn't we? 2 is the greatest common factor of 10 and 2, and x squared is the greatest common factor of x cubed and x squared. So I'm going to leave the numerator alone for now. And on the bottom, I am, as you suggested, going to factor out 2x squared. If I factor out a 2x squared, what's left? Minus 1. Great. Now what? Do you see anything that can reduce? I do. Can that reduce? Yes, 2 over 2 would be 1, and then x cubed over x squared is x. So on the top, I'm left with x, and on the bottom, I'm left with 5x minus 1. And that's because, this right here, 2x cubed over 2x squared reduces, 2 over 2 cancels, and I'm left with x cubed over x squared, which is just x. God bless you, my child.
Thanks.
And that's where this x on top came from. Make sense? Mm-hmm.
What was the last part?
Oop. Beautiful. All right. Now, when you look at this problem, I know what you're thinking. You're thinking, Taylor, will you stop using z's as a variable? Your z's look ridiculous. And then the second thing you should be thinking is, I wonder if anything can factor. You see any factoring that can be done? Mm-hmm. 5 where? Everywhere? Well, I got to leave the top alone, right? There's only one term in the top, so I got to leave that alone. Can I factor 5 in the bottom? Is that all I can factor in the bottom? How about 5z to the 4th? What am I left with? 2z, or not 2z, minus 1. Now that I've got it factored, do you see anything that can reduce? Yeah, we've got 5z to the 4th on the top and 5z to the 4th on the bottom. What is 5z to the 4th over 5z to the 4th? 1. Anything divided by itself is 1. So my answer here is 1 over 2z minus 1. Hey, that does not seem bad at all. That's pretty manageable. I think I can live with that. Ooh, lordy. I know what you're thinking. I want you to know I'm excited too. Okay, you're probably not that excited. Why are you probably not that excited about these? There's a whole lot of numbers and variables. Can those be factored? Yeah, maybe, but here's why we're not excited about it. They both have leading coefficients and no greatest common factor. So how am I going to factor those two? By grouping. That is exactly right. Factoring by grouping isn't hard. It just takes a little while. I'm going to factor the numerator. Okay, what do we do? Huh? Not yet. When I factor by grouping, I got to split the middle term, so I have 4 total terms.
So 2 numbers.
So A equals 5, B equals 13, and C equals 6. So 2 numbers that will do what? A times C is 30, right?
Yeah, multiply to be.
I need 2 numbers that will multiply to be 30, but when I add them, I get 13.
3 and 10.
How about 3 and 10? That sounds great. 3 plus 10 is equal to 13. Cool. So we take the 5x squared. The 13x now becomes plus 10x plus 3x, and then plus 6 on the end. All right, let's group them. Oof. What's the GCF of those two? How about 5x? That sounds good. Leaving me with
X.
good. Okay, let's group the next two. 3 is the GCF. Leaving me with, oh, that's a relief. So what is my actual factors?
X plus 2 times 5x.
There we go. Great. So back up here at the top, the numerator factors into x plus 2, 5x plus 3. Good news, everybody. Halfway done with the problem. The good news is this is the longest they get. They'll never get any worse than this. I'm just kidding.
I was gonna say, are you thinking this?
I'm just kidding. I'm trying to help you have a positive attitude. It's working. So let's factor this one. This one's also grouping because there's a leading coefficient and no greatest common factor. So I got our A, B's, and C's. What do my 2 numbers need to do?
Are we doing A times C?
Yep.
So multiply to be negative 60 and have to be same.
Yeah, multiply to be negative 60 and add up to be 7. Take your time. Take your time.
Negative 12? Nope. It's 12 and 5. Right?
It's 12 and 5. Good.
Which one is?
-5.
-5. Excellent. 12 plus -5 is 7. So our 7x in the middle is split into 12x minus 5x. I'm going to do 6x squared plus 12x minus 5x minus 10. And now we're going to group them. What's the GCF of 6x squared plus 12x? 6x, that seems good. What does it leave me with? Good. Okay. What about these? What's the GCF? Very good. -5. Remember, if it starts with a negative, you factor a negative. So -5 on the outside. Now be careful when you factor out a negative. Make sure you get the signs right. -5x divided by -5 is x. And -10 divided by -5, +2. So what do these factor into? Great. That is going to be the factors of the denominator. X plus 2, 6x minus 5.
So much.
So, I know this is a really long problem, but as I said, they won't get any longer than this. This is the hardest they get. You won't get any that are worse than this for like at least an hour. Okay, maybe less. Maybe closer to 5 minutes. But do you see anything in this problem that will reduce? Yeah, we've got an x plus 2 on the top and on the bottom. Those are just gone, right? And so my final answer is 5x plus 3 over 6x minus 5. If you leave this final answer with the parentheses on it, it's fine. And if you take the parentheses off, that's fine too. Parentheses are irrelevant in this particular problem. Okay, we're actually going to take a step back a little bit. I'm going to show you some legitimately easier ones here. These are actually easier, not pretend easier, but these are tricky. Oops. What about that one? Now the reason that one looks weird is because in the numerator the x comes first, and in the denominator the x comes last. So I'm just gonna rearrange these. I'm gonna make them look the same. So the x is positive, so when I move it to the front, it stays positive. And the 3 is positive, so when I put it on the end, I make sure it stays positive.
Moment.
So, anything that can reduce here? Yeah, the whole thing. X plus 3 on top and x plus 3 on bottom. What is anything divided by itself?
1.
So the answer here is 1. That seems really easy. So let me give you one that looks just as easy as that, but actually has a little trick to it. Same problem here, which is that it looks confusing because on the bottom the x comes first and on the top the 3 comes first. So I'm going to do the same thing I did on the last one, which is switch the order so the x comes first in both of them, right? Okay. So the bottom I'm just going to leave as x minus 3. Now here's why it's tricky. In the top, the x is negative. So when I move the x to the front, I got to make sure the negative stays on the x. And the 3 is positive, so when I move the 3 to the end, I got to make sure it stays positive. Just because I'm shuffling things around does not give me the right to change the signs. I got to keep the signs the same. Those won't cancel. That's not something divided by itself. Those are different. But what did I tell you about terms that start with a negative? If it starts with a negative, factor out a negative. Exactly right. So let's do that. I'm going to leave the bottom alone. On the top, if I factor out a negative 1, we'll say, because there's no number that's a common factor, let's factor out a negative 1. What am I left with? Negative x divided by negative 1 is x. Positive 3 divided by negative 1 is minus 3. Very good. See anything that will reduce? Now those are the same. But my answer is not 1 this time. What is it? Negative 1. You're going to get quite a few problems that only look tricky because the order is kind of weird. And when the order is kind of weird, you just shuffle them around so the order isn't weird anymore. Like this one looks way worse than it is just because we've got a negative in the middle of the problem. But don't be scared. Just switch the order on the top. Just move them. Now when I move the thing on the top, what's going to happen?
It's going to be -5.
Negative 5x squared, good. Plus 20. And the bottom didn't start with a negative, so that one's okay. Now what? Now let's factor. What can I factor on the top? Yeah, negative 5. That sounds good. If I take out a negative 5, what am I left with?
X squared minus 4.
Very good. X squared minus 4. 20 divided by negative 5. Can I factor the bottom? Nope. Can't do it. Next problem. What are the two numbers that I can multiply for negative 6 but add for 1? Negative 3 and positive 2 would add up to give me negative 1. How about negative 2, positive 3? Now, when you look at what we're left with, you're probably thinking to yourself, there's nothing that can cancel. Like, how am I supposed to reduce that? Nothing on the top is the same as the stuff on the bottom. But
can't you reduce that one?
Which one?
X squared minus 4.
Yeah. I bet I could factor that again, couldn't I? Those are perfect squares. You sound so excited. I love your positive attitude.
Well, I'm actually smart in math for once, so pretty hyped about it.
Smart in math for once. Well, I think that's because your teacher is so good. I think it's because your teacher works out every day. That probably helps. I mean, obviously. What can x squared minus 4 factor into?
X plus 4 and x minus 4?
How about plus 2 and
Or 2.
minus 2?
Yes.
Do you see anything that can reduce now? Mm-hmm. There's an x minus 2 on top and an x minus 2 on bottom. Those can cancel. So on the top I have negative 5, x plus 2. And on the bottom I have x plus 3. Nothing there can cancel or factor. So that is the answer. Whoo! That is awesome. I know you all agree.
Definitely.
You might have been thinking to yourself over the last few weeks, my God, it's nothing but factoring. Why are we doing factoring every week, for crying out loud? Well, now you know. Now that you've got factoring under your belt, most of the problems you're going to do in this class are going to be factoring and then. Factoring, then cancel. Factoring, then graph. Factoring, then solve. We like to factor. When I say we, I mean me, but hopefully you'll learn to tolerate it. Hey, speaking of factoring problems that everybody loves, remember these?
Oh, the cube.
Yeah, do you remember the cubed ones? You do?
Yeah.
I'm impressed. All right. If you remember it, take it away. Here, I'll do the hard part for you.
No, you.
On the bottom, the x comes second, so I'm going to go ahead and flip it. All right, there. I did the hard part. Now you take care of the easy part, which is factoring the cube on top.
No, you can go.
What's A and what's B?
There's
A is x.
that.
What's the cubed root of 64?
No.
Square root of 64 is 8. What's the cubed root of 64?
4.
It's 4. You do have to remember the format, the way it's lined out. What's the first set of little parentheses? It's A plus B. And the second set is A squared minus A times B, or 4 times X, plus B squared, 4 squared is 16. You got it.
Oh, girl.
That's the only thing I got.
That's the only thing you got. You're doing all right. Do you see anything that can factor or cancel? These can cancel for sure. And it just really, really feels like that should factor. X squared minus 4x plus 16 just really looks like it should factor. But there are not two real numbers that you can multiply together to get 16 but add to get -4. They do not exist. So that is the final answer. Sorry to disappoint you. I know you were really looking forward to that one. The cube problems, for real, are the hardest ones. No lie, those are the toughest ones, just because remembering that pattern for the cubed one is so rough. You'll get some that look worse, like this one that I'm about to give you. Looks worse, but I don't think it is worse than the cubed ones. Now, when you look at this, you might think, what are you trying to pull, Taylor? You just said this one wasn't as bad as the cubed ones, and then it's got cubed in it. What's your problem? But since there are 4 terms in the bottom, I can factor that by grouping, and it's not nearly as bad as you might think. Not nearly as bad. I bet you could factor the top with no problems. What can I factor in the top? 2. What will that leave me with? Can y squared plus 1 factor? It looks like it could, but because that is a plus sign and not a minus sign, it can't. If you've got 2 perfect squares, there has to be a minus sign in between. So that one can't factor. I'm done. Okay? But I am going to need some space to factor the denominator. Okay, let's group them up. What's the GCF on those two? Y squared, leaving me with, good, y minus 5. And then we'll factor these two. Yeah, it's 1. Nice. Leaving me with y minus 5. Which means the 2 factors are good. And that is what the denominator is going to be. Y minus 5 times y squared plus 1.
Oh, but wait.
Oh, but wait!
There's more.
There is? What do you mean there's more? That looks pretty good to me.
Can't you? No, you're lying.
I'm lying? How dare you?
Do the y squared thing goes cancel.
Yeah! Y squared plus 1, y squared plus 1, gone. Which means the answer is 2 on the top and y minus 5 on the bottom.
You made me feel stupid for like a second.
Keep on your toes.
I didn't mean to make you feel stupid. It's just a nice bonus.
Great.
I'm always doubting myself and always like, is it right?
You gotta say.
I think a totally valid question to ask might be, who gives a crap about rational functions? That seems like a pretty reasonable thing to ask. Let me give you an example of why you might give a crap. Let's say that you decide to open your very own business where you print T-shirts. We're going to screen print T-shirts. And the function by which you screen print T-shirts looks like this. So let's talk about this function. If I tell you, hey, you did a business and this is the equation, you'd be like, oh, look at that. The math teacher made up a math equation for my business. I'll bet this will totally happen in real life. Let me explain to you what this equation is. Think about screen printing T-shirts. What do you need to do it? You need T-shirts, like blank ones. You probably need, I don't actually know how screen printing works, but like ink or something, whatever it is that you actually put on the shirt to make the design. That stuff costs money, right?
Yeah.
That's why you charge money for your shirts, because the people who buy your shirts have to pay for the supplies. This, if I told you that this was the function for how much it costs for a shirt, this right here, that is the cost per shirt. $3.20 in this particular problem. What then is X?
That means you sell.
This is the number of shirts that you sell. Why is it divided by X? Well, it's $3.20 times the number of shirts I sell divided by the number of shirts I sell, because that's giving me the average cost per shirt. Now, if you forget about this for a second, if you look at 3.2x divided by x, you're like, that's really stupid. 3.2x divided by x is 3.2. So the cost per shirt is $3.20. Duh, you just told me that. So what's the 400? What else do you need to screen print shirts besides a shirt and some ink? You need customers. That's your X. Your X is the customers. What else do you need? If I were to bring you a box with 4,000 shirts in it and some shirt ink, and I said, hey, can you screen print these shirts for me?
Machinery.
You need a machine. I'm not going to go screen print those by hand. Are you insane? 400 is the cost of the machine that screen prints the shirt. Okay, so let me put it to you like this. Let's say that I come into your shop and I say to you, I would like one shirt, please. One shirt. Here's what this function would look like. Instead of C of X, it's C of 1 because I buy in one shirt. And you're like, well, how much is this going to cost my business? Well, it's going to cost me $3.20 for the materials for the shirt, plus the $400 I had to pay for the machine, divided by the number of shirts I sold, which was 1. This is 3.2 plus 400 is 403.2 divided by 1. That's $403.20. So if you open a screen printing business, you buy the machine, and I come in and order one shirt, it costs you, the business owner, $403.20 to make my shirt.
Should definitely cost more than $3.20 for a shirt.
No. We're not saying how much you're charging me. You're not going to charge me $403.20 because I'm not buying it. You're going to charge me $10 or $12 because that's how much a person will pay for a shirt. This is how much it cost your business. It cost you $3.20 in supplies plus the $400 it cost you to make the machine. So if it costs you $403.20 to make a shirt, how does anybody survive in the screen printing business? Well, it's because you don't buy one shirt. You count on volume. What if I said, oh, you know what? I need a shirt for all of the ladies who are in my fan club, so 100. 3.2 times 100 plus 400. I don't really think there's a reason for y'all to laugh at that. You know what? You're not getting a shirt from my fan club. So 3.2 times 100 is 320. So this is 320 plus 400. That's 720 divided by 100. That is... Anybody? Okay, great. Everybody forgot how to divide by 100. Move the decimal. Now it costs me $7.20 per shirt. Now, if I charge $10 per shirt, I'm profitable. I make $2.80 profit on every shirt if I charge $10 a piece and I sell 100 of them. Hopefully, your screen printing business is more successful than that. My fan club is expanding to 10,000.
Wow.
I know 10,000's a little low. There's way more people that would be in my fan club than that, but we're just going to keep the number small so we can do the math. Now what's my cost per shirt? 3.2 times 10,000 is 32,000. That would be 32,400 divided by 10,000. And 32,400 divided by 10,000 is... Now my cost is $3.24 per shirt. So if I say each shirt costs $10, now I'm making $6.76 per shirt. This is one of the reasons why businesses tend to give you discounts if you buy in bulk. The more you buy, the cheaper it is per shirt. So if I open up my business and I only ever get one customer who buys one shirt, I charge them $10, but it cost me $403 to make their shirt. So I lost a bunch of money. After I get 100 customers, I start to be profitable at $10 per shirt. If I get 10,000 customers, now I'm more profitable, or I could even charge less. The guy down the street's only charging $8 for his shirt, so I'm going to go down to $7 and I will still make money. Insurance companies work like this. If I only insure one house with fire insurance and that house burns down, I am screwed. But if I insure 10,000 houses and one of them burns down, I'm fine. The other 9,999 houses that are paying me money for insurance will pay for the one house that burns down. So this is an example of rational functions being used in business. It tells you how much profit you make per item sold. Does anyone have any questions about rational functions?
I just like insurance companies.
Oh, you want to hear more about insurance, nerd?